Hey there, Dangar here. Today's video we're going to look at adding a starter motor to this Tohatsu 40C. It's about a 2002 I think it is. I'm not sure of the history of this motor, but it does seem to have a mounting bracket for a starter motor, so it may have had one previously. Obviously whatever outboard you're doing this on is going to be different, but you may have an easier job of this than you may on some other outboards. But I'll go through all the things you may need to buy or prepare in order to get this working. So the two main things I had to buy for this one was a starter motor, obviously, and some sort of starter relay. Now these are both aftermarket. I got these from Oswide Starters, a company I just found on, you probably can't read that, I don't know why I showed it to you. I'll put a link though in the description to where they are. I originally saw them on eBay when I was getting one for my own motor, and I found it to be really good, and certainly a lot cheaper than buying sort of original Yamaha, Honda, whatever. So I spoke to Craig, who I think runs Oswide, and I said I also needed this start relay. Now you don't need a start relay specific to your outboard. You know, they're all pretty much do the same thing. You know, a 12-volt signal triggers another 12-volt, current. So this one apparently is designed for a Mercury outboard, very common. Also just has a really nice simple flush sort of mounting mechanism, so it should be pretty easy to adapt it to this outboard. It's only really if you're trying to do a real factory fit that you might want to get the specific one for your outboard, but once again, everyone's circumstances will vary. So they're the two main bits of kit we needed. Obviously a battery, so this boat didn't have a battery in it either. And fortunately this outboard does have a regulator in it, but if you don't, then you'll need a regulator to charge the battery. And then we just need some battery leads. So I think I'll start by just going to the chalkboard and just sort of going through a little bit of the theory, not too long, about how this all works, and then we'll start trying to find the wire we need from the forward controls to trigger the starter motor to crank. So there isn't a whole lot to the circuit for a starter motor. It's pretty straightforward. What you've really got is a switch. So you can imagine switch like this when it's open is a normal position, and then when you turn your key to the on position for the ignition on, and then you crank it at extra sort of part of the turn, that's when this switch closes. And then what this switch does is allows some current from battery. So you've got this, let's draw this properly, shall we? So batteries, like this. Allows the current to come through a coil in a relay and then back. So it's just a simple sort of circuit like this. So when you hit on, this current flows. Now when this current flows, it activates another circuit that once again comes from the battery, goes here, goes through this switch, comes out, goes to your starter motor, and then comes back to the negative on the battery. Now, all this is saying is that by activating this current, you activate this little sort of magnetic switch, which then closes this circuit and allows the current to pass. Now, the reason you do this is that this circuit that goes to the starter motor is a very high current circuit, whereas this circuit is a very low current circuit. So they're both 12 volts. And the reason you do this is because you can't have this much current travelling a long distance where normally you want to, or you can, but it's not practical, to have a large current travelling a long distance because you need more expensive wire, thicker wire, and the starter motor needs a high amount of current. And your little switch here can't handle a lot of current. So you can have a really lightweight switch, have the wires travel a long distance, have the switch in a practical position, i.e. up at the helm at the front of the boat, then have this low current signal activate this higher current circuit that makes the starter motor go. So that's what we're looking to build. This section here, which is the switch and the coil, that's the relay we bought, that Mercury relay, and here's the starter motor. And this switch here is the key of the forward controls, and here's obviously the starter battery. So they're the main components. Might seem a little bit abstract like that, but we'll go through and we'll build it from scratch now. So the first thing I'm going to do is take a look at the forward control. And what I want to do is see when a current comes from the battery here into the forward controls, which wire has current coming back out of it when I turn the key into the crank position. So I'm trying to find out which wire is the one that I'm going to have to the input on this relay. So that's kind of step number one. So let's go find that and then we'll go from there. So here we are at the forward control of this boat. And so here's the key, obviously. And so that's the ignition off, that's the ignition on, and it's got a momentary switch, and that's the one that actually cranks the motor. So all I'm going to do is put this camera down here. Oh, sorry about that noise, it's probably quite loud for you. Then grab the multimeter, and I'm setting it at the moment, because I don't even have a battery in, I'm setting it to the capacitance, because I'm going to test some resistance. So all I'm going to do now is these are the wires that come out of this forward control. The red I know is the 12 volt positive, the black's a ground. So all we really need to figure out is whether it's the green or the blue, really. Oh no, we've got a brown as well. So 3 possibilities. So what I'm going to do is just take one end of this multimeter, and let me see how I can rig this up a bit so you can see. So hopefully you can see that multimeter screen all right. What I'm going to do is have a look when I get continuity between the red and the other wire. So if I put this one terminal down to the green, hold the other on the red, now I'm just going to turn the key. Oh, trying to get in the way of the camera when I do that. So if I turn the key, yeah, that goes down to 0.2 of an ohm. When I let go of the key, so that's really low resistance there. So looks like we got it first time. So green's it. So just to show you some other ones. So if I said the blue, so I'm connecting the blue and the red. Turn the key, nothing happens. So what we know is that if power is coming from this red, power then gets sent out this green whilst the key is turned in the crank position. So we know when we come down to the end, the green wire is the one we want to attach to our relay. So let's go down to the outboard end now, feed this cable back into the outboard, hook it back up, and see how much length we've got in the green wire and where it goes, and also figure out where we're going to mount this relay. So here we are down at the outboard now. Got this forward control fed back through the hole in the cowling, and we've got the red wire here hooked up to this regulator. This regulator will then hook up to battery power, so whether it's running off the regulator or running off the battery, we'll now have power coming to the forward control. So that's kind of step one. If you don't have a regulator, I'll probably do a video just on doing a regulator rectifier in another video. Essentially what it does is it takes 2 wires from under the flywheel, which are AC lighting coil, rectify that AC current to DC, and regulate it to sort of, I think, 13.8, whatever's kind of a maximum charging current for your outboard, with a fuse in it too. So all you really need to know for this job is that this is the 12 volt DC out from the regulator rectifier. And that's what we're going to have going on to the high current side of our starter motor. But for now, what we're interested in is this green wire. Now this one doesn't have anywhere to connect here. It's just got this bullet connector. So I'll probably strip that off and we'll do a little ring terminal like this on it. But first I'll find a good location to mount the starter relay so we know how far this wire needs to reach. So just quickly for a bit of orientation, as I was saying before, this starter relay is the section inside this, what's now a green box. And we've got 4 pins, 1, 2, 3, 4. And we've also got 4 pins here. We've got 1 coming in here, 1 coming in here, 1 here, and 1 here. So they're the 4 pins. So these 2 larger pins are the pins where the current will flow when the starter motor's turning. And these 2 pins are this red one and this red one. So it's an in and an out. So one of them is a large cable straight to the battery, and one of them is a large cable straight to the starter motor. So that's what those two are. And these two smaller ones here are this one and this one. This is the one where if this current flows through here, it activates this electromagnet, which closes this switch. So when current flows from there to there, it allows current to flow from there to there. So that's how this relates to this part of the diagram. So let's go mount it and hook up that green wire. So somewhere around here seems the obvious place to me. This also has a few pre-drilled holes in it. I'm thinking what I'm going to do, this bracket here really just holds these bullet connectors in place. And isn't that necessary really? So I'm thinking if I lift this out of the way, I can mount it sort of in this space somewhere. So I'll go find some suitable fasteners and I'll look at mounting this. To be honest with you, I guess I'll have to throw the cowling on. The cowling probably comes probably down that way, so I might even be able to keep that tilted up a little bit. But at the end of the day, this will vary from outboard to outboard. The idea is just to find somewhere to mount it where it's not going to short on anything else. And I think this is a good spot for us. So I'll go ahead and fasten it to here and we'll see how it looks.
Across the ballroom floor, you glide. Chandeliers and champagne, all upon you, flowing through your passion desire. The glass slipper falls from your foot, running and stumbling into the darkness, no audience to watch you fall from grace. Down the hall your broken heart races, searching for comfort, a quiet place to kneel and rise up in your own, falling, falling, the voice of reason too high above you.
So this is the finished product. I've removed this little connector housing. I don't need that. Now I'm pretty sure this isn't original either now I look at it, because this has got a connector just hovering in the middle of nowhere. Looking down, I'm a little bit worried about clearing the cowling here, so I might need to bend this back a little bit. But then I've also here got a actually I can probably take that out. I presume that used to be a solenoid for the choke. Anyway, so now what we need to do is I need to connect the green one to here, and then I need to actually get some battery power too. So I'll cut this off. I need to put a green connector onto here and an earth onto here, and that way that circuit, when I turn the key, current will flow across these two terminals from the green wire to ground. So I'll do those two, and then I'll start hooking up my battery leads. So now I've got this mounted up. I just need this green wire, which we know has 12 volts to it when the keys turn to the crank position. Just need to attach it to one of these low current or the activation sort of terminals on the relay. So I'll just cut this bullet connector off and put a spade connector on that. The wire stripped. I'm just going to use a little crimp connector today. Nice and quick and easy. Actually can't find my wire strippers or crimp tool at the moment, so just using some normal pliers. Not ideal, but they do the job. And this relay came with the nuts, obviously, to attach these. It's reasonably arbitrary which of these terminals you go on, because they're just switches. It just flows through. It doesn't matter whether it flows this way, or this way, etc. for either of the pairs. So now we've got the green one here. we just need to get an earth to here. All these black wires are earths. What I'm thinking I might do is cut this bullet connector off and just attach a spade connector where it was, keeping them connected. So I'll do that now, and then we're ready to move on to these battery leads. We now have this activation circuit reasonably complete. The reason I say reasonably rather than complete is that power still needs to get up to the control box in order for it to come out through this green wire when the key's turned on. Now, the best way to do this, and the way it's generally done, is that I'll attach the battery to this terminal of the relay, but I'll also put this on. It's quite often the point where the main battery positive terminal comes into the boat and attaches to the starter relay is a really common place to also just hook off other 12-volt feeds. Those feeds aren't necessarily related to starting the boat. It's just a convenient post to get a really clean, straight 12 volts in the battery. So I'll show you the battery leads I've made up now, and then we'll attach those to the battery. So I've got two leads for the battery, positive and negative one. They're reasonably thick leads, as you can see, and that's mostly because of the, well, pretty much solely because the starter motor actually draws quite a lot of current. So this positive lead I'm going to run from the positive battery to one of the high current terminals on the relay. But I'm actually going to cut a small chunk out of this one and then re-terminate both ends because I need a small amount of thick cable to go between the output of the relay to the starter motor itself. So I'm just going to cut this one maybe 6 inches off, and then just put a couple of similar terminals on the end of each one. So we'll do that quickly and then we'll start up again. When I do these bigger type of terminal lugs, I tend to like just doing them in a vise. So I'll just get it lined up and then just use the vise to clamp down on it. I think they're a bit too big for pliers or anything like that. Then you'll end up with a really nice solid connection. Just do a bit on this corner as well. So it ends up pretty squished, but it's a really strong connection. Then after that, just gently, just put a bit of large heat shrink on it, just down to a little bit over the metal, and just heat that up. Alright, all good to go. So I'll do that to the other end of the one I cut, and then we'll start connecting. So our battery just has these sort of traditional top posts on it. So I'm just going to pop a couple of these adapters on that will give us the smaller sort of wing nut attachments that we can put these new leads on. A lot of marine batteries will actually come with both types of terminals on them. This one's actually just a car battery I've had floating around the workshop. Okay, so I'm going to attach this positive terminal first. So there's no ground currently on the boat for that positive terminal to knock against. So once we've got this wired up and secured, I'll put the ground in. So now I've fed this positive from the battery through the cowling, I'm just going to pop this onto one of our two larger terminals from the starter relay. I'm also going to put the positive from the regulator rectifier, and then we'll just put a nut on here and lock that down. Next thing I'm going to do now is mount the actual starter motor. So we're lucky in that we've got this mounting point for the starter motor on this motor. You may need to buy just this mounting bracket if the one you own doesn't come with it. flywheel also has the ring gear around the outside the starter motor engages with. Some pull start only motors won't have a flywheel with the ring gears on it, so you may need to swap that flywheel out as well. But in this case, we're lucky in that we have the ring gear, flywheel, and the mounting bracket, possibly because this actually did have a starter motor at some stage in its life, but certainly hasn't when it arrived here. So I'll just bolt this starter motor onto here, and then we'll start wiring it up. Now the reason I haven't had the positive terminal connected yet is because, for example, doing this nut up, every time I touch sort of across here, I'll be shorting things out. So by having the negative disconnected, we don't have any current flowing at the moment. All I'm going to do now is take my other thick black lead, go from the negative of the battery, and I'm actually going to take this nut up and attach it straight to the bolt that holds the starter motor onto the casing to give it a really good connection straight to the starter motor. So we'll hook that one up, and then we should be good to test. So this negative lead or ground lead is the last piece of the puzzle. So now that's connected to the battery and comes up through the cowling and connects to the bolt that holds the starter motor to the outboard itself. So the whole outboard is ground. Anywhere you can touch metal on the outboard is ground. So to talk through it, I guess, well, actually we should test it first, shouldn't we? Be confident, aren't I? Hang on. Okay, good. It's not making a liar out of me. So let's talk through just sort of the whole circuit again quickly, just sort of hopefully clarified a little bit. So it all starts the battery. Power comes in through the thick red lead, comes up here to a terminal post on the starter motor. This is just used as a convenient place to pick up power to send to the forward control unit. That could be picked up right at the battery if we wanted, but it's just a convenient place to do it. That power then goes to the forward controls, and when you turn the key into the crank position, that power gets sent through this green lead and connects here to the sort of activation circuit of the relay. It then passes through a magnetic switch to ground, this black wire, and when it does that, power is allowed to pass from here to this short lead to the positive of the starter motor, run the starter motor, negative, straight back to the battery. So that's how that circuit works. And also power from is generated under the flywheel for the lighting coil. It's regulated and rectified here and connects to the battery here as well. And this is the path by which the battery can be charged by the outboard as well. At this point, it's probably useful to also sort of say that, so when the power comes in from the battery here and it goes up to the forward controls through this wire, and then when you turn the key, all it does is send power to this green wire. So if the key mechanism wasn't working, all I really have to do is have that power touch here and it'll start, provided the ignition's on. If that solenoid has failed and your ignition's on, all you need to do is touch these two. They'll spark a bit more. Sorry, bumped the mic there. They'll spark a bit more because that's actually then conducting the full high current through the pliers. Obviously be careful, you know, you will get sparks, so if there's any petrol fumes, bad thing. Obviously these also have insulated handles. But just be aware that all you're really doing to start it is to have power come from here to here. You can do that if the solenoid's functional by sending power from the positive to the plus 12 volt side of the relay, or you can simply short these out. The engine actually needs to have the ignition on to run, which sort of a little bit counterintuitively is actually disconnecting a wire, because when the ignition's off, a wire gets joined that earths out the CDI unit so that the capacitor inside can't actually charge. So the current from the coil under the flywheel gets sent straight to ground instead of charging the coil and therefore firing the spark plug. But if you're having trouble with your boat and you need to start it, that's one way you can do it. Well, that's about it for this video. I hope you enjoyed it. I hope it made sense. It's a relatively simple circuit doing a starter motor. And I'm hoping that the knowledge you sort of gained watching this video will also help you if you're looking to diagnose and repair a starter motor that's not working, or the whole starter motor circuit that's not working. Being able to figure out whether it's that relay, if you turn the key and current's being passed, or whether it's the starter motor itself, or the battery of course. So if you also do that diagnosis and you find your starter motor is not working, take a look at the how to repair a trim tilt video, because that one shows repairing an electric motor, which is pretty much the same whether it's a trim tilt motor or a starter motor. So that might help you if you've diagnosed it and you've found that the problem actually lies with the starter motor itself. It's now the 23rd, so by the time I upload this, particularly given my internet speed, it's probably going to be Christmas. So I hope you all have a Merry Christmas and a Happy New Year, and I'll catch you soon. See ya. Bye-bye.